We are given a rational function, basically a big fraction, x over x squared minus 5x plus 6. We're asked to decompose it via partial fraction decomposition. First thing we're going to do is factor and decompose. Okay, factor and decompose. Okay, so this is equal to x. I have no equal sign written. I just write x. Now I'm going to factor it, and I'm going to just factor by guessing. Looks like we can go all the way down to first degree factors. X minus 2 times x minus 3. Now, since the bottom is just 2 first degree factors to the first power, the method of decomposition will look like this. It's going to be equal to some number a over the first factor to the first power. And there's no higher powers of x minus 2, so we can stop there and just write plus the value b over the second factor to the first power, x minus 3 to the first power. Now, if there had been a higher power, we would have gone further. If there had been second degree factors, we would have done an even more interesting thing, but this is pretty simple one to start out with. Okay, so at this point, we can see that we want to get rid of the fractions. So we're going to multiply both sides by the LCD of all these fractions, and the LCD is equal to x minus 2 times x minus 3. See, this is going to get rid of the denominators. So here we go. We're going to go the first x times the LCD x minus 2 times x minus 3 all over the original denominator x minus 2 times x minus 3. Bring down the equal sign, then a times the LCD x minus 2 times x minus 3 over the original denominator there was x minus 2. Bring down the plus b times the LCD x minus 2 times x minus 3 over the original denominator, which is x minus 3. And we're going to get rid of this factor, and get rid of this factor, and get rid of both of these factors. Yeah, we got rid of all the fractions. So that gives us x equals, now on the second term we have a times parenthesis x minus 3. We're going to just distribute the multiplication, and we'll get a times x minus 3 times a, and then the plus sign. B is going to now be distributed across the parenthesis. B times x minus 2 times b. Okay, so now we are going to arrange the coefficients. Arrange coefficients. Okay, so on the left side, all we have is x, and the coefficient is the invisible 1. So this is just 1 in parentheses, that's the coefficient, times x to the first power, equals, okay, now on the right side, we have something times x. It's more complicated. Let's see, we've got a, and we also have plus b. Those are each multiplying x, so we'll put them in parentheses and have them multiply x, a plus b times x. Okay, and then what's left is what we call the constant coefficient at the end. It's just the values that have no variables. And that would be plus, let's put it in parentheses, negative 3a, that takes care of this guy, minus 2b. Okay, so now what we're going to do is equate the coefficients on each side of the equal sign. Set them equal to each other. Equate coefficients. Okay, so the coefficient of x on the left side of the equal sign is 1. The coefficient of x on the right side is a plus b. Now that means that 1 is equal to a plus b, but let's write it this way. Let's write it as a plus b is equal to 1. Okay, that's the result of equating the coefficient of x on the left side with the coefficient of x on the right side. Now let's equate the constant coefficient on both sides. Let's look at the right side first. The constant coefficient, the value that has no variable x in it is negative 3a minus 2b. Let's write that down. Negative 3a minus 2b equals the constant coefficient on the left side of the equal sign. Well, there's only 1 times x over there. That means the constant coefficient is simply 0. That's all that means. So we factored out the coefficients of each of the powers of x, including the constant coefficient, and then we equated, we set equal to one another the coefficients. So that gives us equation, we'll call it equation Roman numeral 1 and Roman numeral 2. Okay, so the Roman numeral 1 is the coefficients of x, and Roman numeral 2 are the coefficients of the constant. So now we're ready to solve the system. Because we formed this system of equations in variables a and b, and solving that will give us the values to plug into the final answer. So what we're going to do here is eliminate the variable a. We'll eliminate a, and we'll do that by taking 3 times equation I, and we're going to add that to equation double I, and that gives us the following. It gives us 3 times a plus 3 times b equals 3, and we're adding that to equation double I, which is negative 3a minus 2b equals 0 parenthesis, add, and we get, well, these guys cancel, and this leaves us b equals 3. Okay, so we're partway there. We've got a value for b, and now that we have a value for b, we can substitute that into equation I, and that gives us a plus the 3, in other words, a plus b equals 1, and that means that a is equal to negative 2. All right, conclude. This is the biggie. Take that first step that we did, which is up here. I'll draw a happy face to remind you. Happy face right here. Take that result and replace the a and b with what we just found. So we have x over x minus 2 times x minus 3 equals, don't write the a, just draw the line and then the x minus 2. And then the plus sign, don't draw the b, just draw the line and x minus 3. Now plug in a for the first numerator. That was negative 2. We just found negative 2. And then plug in b for the second numerator. That was 3. And we are finished. We have done a partial fraction decomposition of the original problem.